Hi, I'm Vinod. In the previous set of videos, we went over the RTN designs for an adder and a traffic signal controller. We also went over concepts related to a finite state machine and pipelining. In this video, we will look at some typical aspects of a chip. As we'd seen in an earlier video, a design has input pins through which it receives inputs, output pins through which it sends outputs, data path, the path through which the data flows that contains data flops, control path, the path that contains the control logic, which could be a state machine that contains control flops. Right from the early days of computer architecture, large memories typically reside outside the chip. Memory resides outside as integrating memory cells and logic cells is not efficient. Hence, they are made into separate chips, namely process chip and memory chip. Over the years, though the transistor size has reduced, more and more functionality has been added onto a chip. But the chip has always been pad limited. That is, the form factor of a chip has mostly remained the same. This means that the number of physical pins through which the chip receives inputs and sends output has not grown in numbers. In a typical 10mm by 10mm chip, the number of I/O pins or pads is typically around 150 to 200 pins. If a chip is perceived as a function, then its inputs control its functionality and its outputs provide a way to observe its output behavior. Since a chip is pad limited, a chip's controllability and observability are limited. In order to enhance the controllability and observability, and in order to provide configurability, all chips have control status registers or CSRs, which are also typically implemented using flops. The CSRs can be considered to be similar to a remote control of a product. For example, the remote of a television. The television can be perceived to have the functionality to receive transmitted video and audio signals and to display and play these signals. The configurations in the remote let the user control the audio and video quality among many other features. Similarly, the chip, being a hardware product, provides configurability of its functionality through the presence of CSR. Applications that sit right on top of the chip and interact with it would configure the control registers right after resetting the chip. The chip processes or performs its functions based on these configurations. During or after the processing, the chip writes the information about the processing to the status registers, which the applications can read and interpret as needed. All chips have CSRs. More complex the functionality of a chip, more number of control status registers in it. We will continue to look at the typical aspects of a chip in the next video. Happy learning.